Hello friends, I am going to make a new video for you guys on finding the area of a non-right triangle. This will be one of the notes from this week that I want you to complete. And so I want to start with thinking about what we already know. So something we already know from the past is this idea of the area of regular triangles, right? How do I find the area of a triangle? And so if I had just any one of these three forms right here. In each situation, we have a height or an altitude that can be determined. Here it's this, here it's this, and here it's outside the triangle. But in each instance, we have a right angle that we are really working with to help us determine the area of these triangles. And in each one of these cases, the base is always where the height would intersect it. So here's kind of a different version because we've had to set it outside of the triangle. But if you were to imagine this continuing on, then it would hit over there. So hold on just a sec. Let me, pin's not liking my new fancy desk here. Let's see if this will do it. Well, maybe not. So in this case right here, we would take 3 times 4 times a half, and we would get 1/2 times 3 times 4, and we would get 6 here. And here we would get 1/2 times 5 times 6, which is going to be 30 divided by 2, which is 15. And here it's going to be 1/2 times 3 times 8, which is going to be 24, 12. So down here, we're going to say, what happens if I'm not given a height? How can I figure this out? So what we're going to say is that, well, I have this angle here, and if I wanted to, or if I happen to know it, that height would be right there, right? That would be where the height is. So we'll say, I'm going to call this guy X. And if you look at it, just right here at this little portion of the triangle right here, that's a right triangle. And with this right triangle, I can find this side length. I can say this side is opposite this side, and this side right here is the hypotenuse. So we could say that the sine of 30 is going to be the opposite over the hypotenuse. Okay? And if you plug that into your calculator, you're going to get, let's see if you guys can see my calculator here. It's not great, it'll do. So we'll go into our calculator, and the first thing you're going to do is you'll do the tangent of 45, and the tangent of 45 is 1, only in degree mode. So since all of these questions are in degrees here, you're going to want to make sure you're in the right mode all the time. So we're going to say that, where are we? 3, multiply that 3 over. 3 times the sine of 30 is that height. So 3 times the sine of 30 is 1.5. So 1.5. So if we wanted to from there, we could say, all right, this guy right here is area of the triangle is going to be 1/2 times the base, 7, times the height, which we got to be 1.5. And we would get, you could do it on your calculator, you could do it by hand, I don't care, 0.5 times 7 times 1.5, and we would get that this is going to be 5.25. So we were sort of able to circumnavigate this not having a height here by using some trig to help us figure out what it is. So the question then becomes, can we sort of create a rule thinking about this process, right? Can we think about the process we did here? Can we make a rule using this idea? So we're going to say that this triangle right here, I'm going to call this guy ABC, triangle ABC, and little a is always across from big A, little c is always across from big C, and little b is always across from big B. I could put the letters A here and B here and C here. However, it doesn't matter how you do it. It's just important that these big letters and the lowercase letters are opposite each other always. That's sort of a construct of geometry. So the area of this triangle is going to be 1/2 base times height. That's the way it always is. So the base is going to be this little b here, and the height, we're going to see if we can figure out this height in terms of these other pieces of information we have. So we don't always have to figure out this length. Can we figure out something that's in terms of these other letters? So what we're going to say is we're going to do the same thing we did above. We're going to say that the sine of this angle C right here is going to be the height divided by sine A, because the height is the opposite. And here it's kind of confusing because the A, we tend to think of A as adjacent, but here, since it's opposite the right angle, this is still our hypotenuse. So side A, here is our hypotenuse. And the height is our opposite. So then we're going to say, we're going to abbreviate height as H and A, that side A as A. And so can we rearrange this so we have something that H equals? And sure, we can. We can multiply that A over. And we're going to get H is the side A times sine C. So now I've got this, and I'm going to replace it in that formula over here. So the height is just A times sine C, because that's the height. So then this becomes our rule, right? So the rule becomes 1/2 A times B times the sine of the angle between them. Now, if you'll notice here, I kind of put some notes underneath it. And the reason I did that in this situation is because I wanted you to recognize that, do you remember earlier when I said that A could be here and B could be here and C could be here? It's like that those letters are irrelevant. What's relevant here is that I have a side and I have another side, and then I have the angle between. Okay, that's important. So this is always the included angle. And the way you know that's included is because I have 3 different letters. I have A and B, which represent 2 sides, and then C, since A and B must be these points, then little a and little b must be opposite those, which means the remaining letter has to be between those angles. In all triangles, that's true. So let's do a couple examples of where we might use this. Okay, so here, again, we could solve for this angle and make all of that mess, or we could use the formula we just created, which also is conveniently on your formula sheet. So, yay, formula sheet. So we'll say 1/2, here's our side, here's our other side, here's the angle between. So 1/2 sine 40. You could write it like that. And you could multiply it by the 2 side lengths. Remember, multiplication is commutative, so you can write it however you want. So I'll go to my calculator, yay for us, and living in a world with calculators, and we'll say 0.5 times 6 times 7 times sine 40, and we'll hit enter. And remember, if you don't get the same answer than me, it's probably because you're not in degree form and you're in radian form, so always make sure you're in the right mode. And so what we're going to get here, still 3 sig figs, is going to be 13.5 square units. Okay. Here's a different kind of example where instead of finding the area, we're given the area and we have to find the angle. So we'll set it up. We'll say 11.5 is going to be 1/2 times 5 times 6 times the sine of theta, which is the angle between those 2 sides. And you can set it up and solve it by hand if you want to, or if you wanted to be lazy about it, you could do our handy dandy numsolve. Oops, that's in algebra. I know you guys know where it is. 11.5 equals 0.5 times 5 times 6 times the sine of x, comma, x. And I'm not sure if you guys, if you saw what I did there, but before I hit comma x, I kind of clicked over so that I was outside this parentheses. If you get the comma and the other x inside the parenthesis for the sine of x, it's gonna freak out. So you gotta make sure you get it outside that sign. And then hit enter, and it's gonna say 50.05 degrees, which is gonna be approximately 50.1 degrees is theta. Okay. The last one here is a little bit different, where we're not actually given an included angle, but if you look at it, we know that the degrees in a triangle makes 180. So we'll just say 180 minus 40 minus 30 is going to give us that last angle. I know that's kind of hard to see, but this angle ends up being right here, 110. So we end up getting 110 for that. So what we'll say, just like we did before, 1/2 times side included angle, 8 times 7 times the sine of 110. So 0.5 times 8 times 7 times the sine of 110. And we're going to get that this area is approximately 26.3. Okay. And most of the questions you guys have are just like this, where you're either doing something really straightforward, finding the area, you're finding an angle when given the area, or maybe you have to do a little bit of problem solving to find some missing information and then finding the area. So I hope this helps you guys, and I will hopefully get to see you soon. Bye.